The average forward-deployed engineer is making 40% more than their backend counterparts, and companies still can't hire enough of them.
Wait, 40% more? What exactly are these engineers doing that's worth that premium? So we're breaking down what FDEs actually do, the skills you need, and how to position yourself for these roles?
By minute 4, you'll know exactly how to pivot your career toward this $300K sweet spot. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today we're diving into why the forward-deployed engineer is tech's hottest job.
Stick around to the end for this week's headlines. Let's dive right in.
So, forward-deployed engineers. This role is suddenly everywhere. I've been tracking job postings, and in the last 6 months alone, we've seen a 300% increase in FTE positions across major tech companies. But here's what's fascinating. This isn't just another trendy job title. This represents a fundamental shift in how companies are thinking about technical talent.
Yeah, I've been seeing these posts all over LinkedIn, but what exactly makes this different from, say, a solutions architect or a technical consultant? Because on the surface, it sounds pretty similar.
That's the key question. The forward-deployed engineer sits in this unique position. They're not just advising or architecting. They're literally embedded with the client or internal team, writing code, debugging systems, and solving problems in real time. Think of it like the difference between a doctor who prescribes medicine versus a surgeon who's actually in the operating room.
So they're hands-on throughout the entire process.
Exactly. And here's where it gets really interesting. Palantir coined this term, borrowing from military terminology. In the military, forward deployed means you're stationed overseas, ready for rapid response. In tech, it means you're stationed with the customer, ready to respond to their technical challenges immediately.
That makes sense, especially with how complex modern platforms have become. You can't just throw documentation over the wall anymore.
Right. And the timing isn't coincidental. We're seeing this explosion in FDE roles precisely because of AI. Companies are desperately trying to implement AI solutions, but the gap between the technology and practical business implementation is massive. Traditional consulting models are too slow, and pure engineering teams are too removed from business context.
What kind of skills are these companies looking for? Because this sounds like you need to be both deeply technical and business savvy.
It's a rare combination. Based on job postings I've analyzed, companies want full-stack engineering experience. We're talking 5 to 7 years minimum. But they also want people who can present to C-suite executives, understand business metrics, and translate between technical and business stakeholders. Salaries reflect this. I'm seeing ranges from $200K to $400K base, plus equity.
Those are staff engineer numbers.
Sometimes higher. Stripe's FDE positions for their payment platform integration can go up to $500K total comp. And that's because these engineers directly impact revenue. When you help a major retailer integrate Stripe and process millions in transactions, you're not just writing code, you're enabling business outcomes.
So is this sustainable, or is this just a temporary response to the AI adoption challenge?
That's what we need to unpack. Coming up, we'll dig into exactly how companies like Databricks and Snowflake are using FDEs to drive AI adoption, what the day-to-day actually looks like, and whether this represents the future of engineering roles or just another Silicon Valley trend. Let me paint you a picture of what this actually looks like in practice. I spoke with a forward-deployed engineer at Databricks last week, and their typical week is nothing like a traditional engineering role. Monday, they're on site with a Fortune 500 retailer debugging why their recommendation engine is producing biased results. Tuesday, they're writing custom Spark jobs to handle the client's specific data format. Wednesday, they're in a boardroom explaining to executives why their data quality issues are blocking AI implementation.
That's incredibly varied. How do they maintain technical depth while juggling all these different contexts?
That's the challenge. And honestly, not everyone succeeds. The best FDEs I've seen develop what I call technical pattern matching. They see enough implementations that they can quickly identify common problems and solutions. But here's the critical part. They also know when to break the patterns.
Can you give me a specific example?
From my analysis of successful FDEs, three areas stand out. First, distributed systems knowledge, because every enterprise system is distributed now. Second, data engineering, especially with AI, everything comes back to data quality and pipeline reliability. Third, and this surprised me, security and compliance. FDEs who understand regulatory requirements are worth their weight in gold.
That makes sense. They're often working with sensitive customer data.
Exactly. Now, here's your interview checklist. Ask about the support structure. Do they have senior FDEs who mentor newcomers? What's the escalation path when you hit blockers? How do they handle knowledge transfer? If they can't answer these clearly, that's a red flag.
What about compensation negotiation?
FDE roles often have variable comp tied to customer success metrics. Make sure you understand these metrics and that they're within your control. I've seen FDEs whose bonuses depended on factors completely outside their influence. That's a recipe for frustration. Also, negotiate for learning budgets. The best FDEs constantly upskill, and companies should support that.
What about for companies considering building FDE teams?
Start small and be selective. Your first FDEs set the culture and patterns for everyone who follows. Look for engineers with consulting or customer-facing experience. Teaching technical concepts is a skill that needs development. And, critically, create feedback loops between FDEs and product teams. FDEs see customer pain points firsthand. That intelligence is gold for product strategy.
How do you measure FDE success?
This is where many companies fail. They use traditional engineering metrics like lines of code or tickets closed. That's wrong. Successful FDE programs measure business outcomes, time to value for customers, adoption rates, revenue enabled. One Databricks FDE told me their primary metric was time from POC to production. They cut it from 6 months to 6 weeks on average.
That's massive impact.
And it highlights why this role exists. Traditional engineering optimizes for scalability and elegance. FDEs optimize for business value and speed to market. Both are necessary, but they require different mindsets and skills.
So where does this trend go from here?
I see 3 futures. In one, FDE becomes a standard career path, like SRE did over the past decade. Companies build mature programs with clear progression and specializations. In another future, AI tools reduce the need for human FDEs. Automated implementation assistants handle the routine work. The third future, which I think is most likely, is hybrid. FDEs become more strategic, using AI tools to handle implementation, while they focus on complex problem-solving and stakeholder management.
That actually sounds like the evolution of many technical roles.
Exactly. The engineers who thrive will be those who can work at the intersection of technical depth and business impact. Whether you call them forward-deployed engineers, solutions architects, or something else entirely, the need for technical professionals who can bridge worlds isn't going away.
Any final advice for engineers considering this path?
Try it in small doses first. Volunteer to work directly with customers on a project. Join sales calls to understand business conversations. Build something that solves a real business problem, not just a technical one. The engineers who excel as FDEs are those who find energy in this intersection of technology and business impact. If you find yourself drained by customer interaction and context switching, that's valuable self-knowledge too. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in healthcare platform engineering. Artera is leveraging AWS to revolutionize prostate cancer diagnostics with their AI-powered tool, Artera AI Prostate. According to the AWS architecture blog, they're processing massive medical imaging datasets at scale.
That's a perfect example of platform engineering enabling precision medicine. What kind of infrastructure challenges are they solving?
They're dealing with gigabytes of high-resolution pathology images per patient, requiring robust data pipelines and ML infrastructure. The platform handles everything from image preprocessing to model training and inference at scale.
Speaking of scaling platforms, Cloudflare just published an interesting piece on vertical microfrontends. They're enabling teams to own entire application slices independently, like having one team manage /blog while another handles /docs, each with their own tech stack.
That's a game changer for platform teams. Instead of wrestling with monolithic front ends, you can give teams true autonomy while maintaining consistency.
Exactly. The Cloudflare blog details how they're using workers and their edge platform to make this seamless. It's essentially applying microservices principles to the front-end layer.
And for those managing databases, Datadog just integrated Explain Analyze functionality directly into their database monitoring for Postgres. No more context switching to debug query performance.
That's huge for platform engineers supporting database infrastructure. How much detail are they providing?
According to Datadog's blog, you get full query execution plans with actual runtime statistics right in the monitoring interface. It shows exactly where your queries are spending time, whether it's sequential scans, index lookups, or join operations.
That's going to save so many debugging hours. Platform teams can now correlate query performance with infrastructure metrics in one place.
That wraps up this week's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.